Okay, so after today, I felt the need to make a video for vectors. Very, very hard to get, very complicated, um, and sort of hard to understand. Um, if you don't, all this like geometry kind of new, and the wording is really stupid. But I want to see if I can make this make the most sense to everybody, including me, because I don't fully understand it still, probably, and um, probably also gonna fail the test. But let's just go over number 2, which is one of the easier ones in the packet, unfortunately. So, start off with this is probably gonna have a part 2, by the way. It's probably gonna be long, but start off with okay, so post office person does 22 kilometers below. Um, so this one's kind of easy compared to like number 4 and 5. On page 4, where it's not directly going through stuff, it's or even 3. Um, so I eliminate one step, but so then you have 47 kilometers, 60 degrees south of east. So you have your 22 kilometers here. Then you have 47, which is going to be long, like this. Maybe not that long. No. We'll just go that long. So then you have this one being 47 kilometers, and you've got to remember that this is 60 degrees. Now, whenever it gives you a degree for your vector, you have to know where that degree is at. So, the way I like to think about it, right, is which way looks like 60 degrees. So, you can have an angle, if you draw a straight line here, you can have an angle here, or you can have an angle here. Which one looks like 60 degrees? Not this one. This one's a really big angle, right? And that ends up being 120, right? This is a really big angle, right? There's no way that can be 60 degrees, right? It has to be an acute angle, or a small one. So this would be 60 if you drew your line there, right? So that's just how I like to think about it. You can do the same for this one, but it doesn't give an angle for that one. So now, since we're trying to find the displacement, we connect the two, like that. And this kind of looks like 90 degrees, but it is not. It is not 90 degrees. It's not even close. So the picture might be a little off, but oh shoot, but that's fine. So you know what? I'll give you guys a rundown of my steps. So step 1, draw vectors and angles 2. Draw the line draw the line of displacement, I'll call it, which is this brown line right here. 3. Make your right triangles. You'll see what I mean by this in a second. 4. Use your trig. 5. Find your coordinates. Okay, so that's how far I'm going to go right now. So, we did step 1. Draw your vectors and angles. We did that. We drew the line of displacement, which is this. Line right here. I'll put a question mark because we don't know that. That's what we're trying to figure out. Since it's not a right triangle, we cannot use right triangle trig. It only works when it is a right triangle. You cannot use it on any other triangle in the world. There's no other triangle you can use it on. You can't use Pythagorean theorem. You can't use anything that was in that packet, the trig packet that we got. You cannot use for any other triangle than a right triangle. So, you have to think about it, and you have to make yourself a right triangle. Now, how are you going to do that? You already have this 60-degree angle right here, and you have this little line going from it. So why don't we just make that into a triangle? Is basically what the problem maker wants you to think. So you do. This 47 kilometers is cut off, but that's fine. So you do. Right? You make it into a right triangle. Basically, you make a square that's cut in half, is basically what you want to do. So now, you have this right triangle in red, and you have the original triangle in brown, red, and black. So, this is a right triangle, right? So that's step 3. And now we do step 4, which is use your right triangle trig, since it's a right triangle. So, let me get a different color. You do sine of 60 is a over 47. Another hard part to add on to all the other hard parts is figuring out which angles are A and B and which sides are A, B, and C in the right triangle. The answer is this line right here is usually going to be C. It's usually going to be your hypotenuse. And how I like to think about it, every trig function uses angle A. Sorry. Yeah. Oh. I got it. Okay. Wait. I think Miss Butler messed up again. Hold on. Hold the phone. I don't know if it matters. So, let's just take it from here. So this should be 30. Nope. I'm right. Oh shoot. So, this doesn't look like it, but this is angle A. Source, trust me. Okay. So you get your trig. So you take angle A, plug it in with sine, equals A, which is this side, over 47. Okay. So then you just do the math. So it ends up being 0.866, 0.866 equals A over 47. Yeah, there's definitely going to have to be a part 2. Sorry about that handwriting. And that equals 40.7. Yeah, so this side right here is 40.7. Yep, that's correct. Okay, I'm sorry about that. It just doesn't look right. But I don't even know anymore. I'm trying. Anyways, so then we do the same thing with cosine. It's just cosine is B over C. So cosine of A, which is 60 again, equals B over 47 again. Now you could use Pythagorean theorem here if you wanted to. Pythagorean theorem is more writing with your mouse or like drawing, and I don't like that. So I'm just going to do this. And it's kind of easy because the cosine of 60 is 0.5. Or like 1/2 basically. So then you get 0.5 equals B over 47. And then you get 23.5. So you have here B here, and you have A here. What does this tell you? Well, it tells you what you need for your coordinates. Okay? This video is going on 15 minutes, so I'm gonna have to end it here. If this made sense, good. If this didn't, I understand. But I am also confused. Okay? I'm trying to figure this out, and we have a test in 2 days, and what the heck?